All right, ship heads. Oh, heads crew. Okay, so I get the wordings. Heads cruises, can't sight, I guess. At 6.19 meters per second at 57 degrees north of east. And these are all going to vary now, right? So north of east, relative to the water within a current that flows due northeast at 6.33 meters per second. So let's deal with, let's deal with the ship first?
Yeah.
Right? So let's.
Yeah.
So let's get that one resolved. So the ship is heading 57 degrees north of east. So this is east,
Yeah.
right? We're going to tilt up north of east, right? 57 degrees. And so the ship, what color is our ship? Our ship is going to be green.
You start at east and move north, right?
Exactly. Yeah. So if it's north of east, that means it's starting at east and moving to and swinging to the north.
And if there's east and north, you start at north.
Start at north and swing to the east. Exactly. So this is 57 degrees. And this is 6.19. I'm going to suppress the units so we don't have to write so much. And we want to break this into components, right? Okay, what are my components going to be?
X and Y.
Okay, X and Y, right? So we've got this component and that component at right angles. Okay. And based on my picture, what's my Y component going to be? Now don't say it out loud. I want everybody to take a peek at this. Think SOHCAHTOA, right? Think SOHCAHTOA. There's my right triangle. The 57 is the angle at the bottom left, correct? Okay, so stare at that.
We're trying to find Y, you said?
Yes. Well, I want to find both the Y and the X components. See if you can write those down. And then we'll see if everybody's on the same page. Okay.
Yeah.
Okay, Jordan, what'd you get for the X component for this one? Okay. Okay. Can you tell me this? Can you tell me, this is going to be the X component, right? Can you tell me which sine or cosine is going to be what we're going to multiply by there? Okay, let's draw a right triangle. So there's my angle theta. There's the right angle, correct? Okay, so we got to label the sides. If that's my angle, I got to label adjacent, opposite, and hypotenuse, right? Because we just need to know based on this relationship which one goes where. Okay, so label this for me. That's going to be your task, and then I'm going to spread the wealth here, and a lot of people can contribute to this. So tell me where the hypotenuse, which one of those would be hypotenuse? Good. Opposite the right angle. Good. Okay, Jordan, can you tell me which one's opposite? Okay, good. So that must be adjacent. Okay. So now, what does this tell me? Sine, the sine of theta is the ratio of what divided by what? Good. Cosine is? Perfect. Tangent is? Okay, so then let's label these sides. There's my 57. What's the 6.19 going to be? That's hypotenuse. Okay, we're looking for this part right here, aren't we? So is that adjacent or opposite? Adjacent. All right, so then if that's adjacent and that's hypotenuse, we're going to multiply the magnitude by which function, sine or cosine or tangent? Cosine, that's it. Right, so then this component down here is going to be 6.19, but it's going to be made a little bit smaller by multiplying it by the cosine of 57 degrees. Okay? Andrew, what's going to be the Y component then? Yeah, so I want to know if we wanted to calculate, we just calculated the horizontal, the X component, right, of this 6.19 meter per second velocity, the ship's velocity, right? The ship is traveling at 6.19 meters per second at 57 degrees, what did we say, north of east. Okay, Jordan just correctly told us that the x component is 6.19 times the cosine of 57 degrees, right? Because that's the adjacent side. What's going to be the magnitude of the y component?
6.19 sine.
Perfect. Good. Times sine. So we're going to take the original 6.19, but it's got to be made a little bit smaller. It's not quite the full deal, right? So we make it smaller by multiplying by the sine of that angle, because 6.19 constitutes the opposite side relative to the 57-degree angle, right? Are you with me? Okay, good. So there's something that's useful. So we got that. All right, so now let's maybe start to build our table down here at the bottom. So we've got vector. We've got the x component. And we've got the y component, right? So for the vector S for ship, the x component was 6.19 cosine 57
How do you know
degrees.
the ship is
Well, because that's what it told
at?
us, right? It said the ship cruises at that velocity and that angle relative to the water. Make sense? Okay.
Oh, sorry.
Does that make sense? That's all right. Okay, so there's the ship. Now let's go back and let's deal with another part of this. Okay, so I'm going to erase this to give us a little room. And I'm recording this, by the way. I updated everything on Friday, so all the videos should be up to date as of today. Let's do the water. Water will make blue, how about?
Yeah.
So the water is flowing due. Northeast, never mind.
So 4, 5.
So this one, we lucked out. This one's kind of an easy one. Everything's to the northeast.
Yeah.
I wanted to get one where they're not. Okay, the other one's
South
not
of
though.
east.
Okay, there's one that's south of east. Okay, good.
But that doesn't.
So this one is due northeast at 6.33. So what's the angle here?
45.
45?
So it's the due part that makes it so it's 45.
Exactly. It makes it right.
Or that they're together one word.
But the other
Right.
ones together won't have to.
Oh.
Okay, so then what's going to be the x component of the water's velocity? What do you think? Autumn, what's going to be the x component of the water's velocity?
6.33
Very good. Okay, and who else wants to contribute here? Matthew, what's going to be the y component of the water's velocity? What do you think? This is 45. The magnitude is 6.33. This is the y component. So is that going to be opposite or adjacent? The angle. It's going to be opposite. Okay, so is it sine or cosine then?
Sine.
Sine, good. So we're going to multiply the magnitude of the vector by sine then to get the y component, right? So 6.33 sine, is that what you're going to say? 6.33 sine 45? Do you buy that?
Sure.
Okay. It's going to be the same number, isn't it? You're right. Okay, so we can add another row to our table. So the water has coordinates, and these are all positive, aren't they? Right? They're all moving in the positive x direction and y direction. Same thing as east and north, right? We take those to be the positive directions. All right, so,
It's never be like southwest.
well, I mean, I'm going to give you some directions like that, but then we'll have to interpret part of these maybe as being negative. Some of the components as being negative, okay? So this one, 6.33 cosine 45, 6.33 sine 45. And now let's go up and deal with this guy riding his
Scooter.
red scooter, how
He's
about?
cool.
So now he's gonna ride his scooter 4.81 meters per second at 45 degrees south of east. So here's that's east, that's north. What is 40, what if it were like, I hate that it's 45, but you guys just lucked out on this problem so much, I can't believe it. How did that turn out? This is the easiest one you could get.
You can divide by square root and
It's really all you're doing, isn't it? So what if it were like 30 degrees south of east? Would that angle be here or there?
There. No, here.
That's the first one.
It'd be
It can be the
here.
first one, isn't it? Because it's starting. So because you're starting at east, south of east. So you're starting at east and swinging south, 45 degrees, right? So this one's gonna look like, there's my 45 degrees, the magnitude is 4.81. And so write down those two components real quick. Okay, Jeremy, what'd you get for the x component?
Well, I don't have my calculator.
Well, I don't need it, just tell me what it would be in terms of sine or cosine. You don't need to give me your,
What would it be, sine?
it'd be right up here?
Wait, oh, cosine.
Cosine, right, exactly, because that's adjacent, isn't it?
Yeah.
Good, very good. So 4.81 cosine 45,
Ooh, the Y.
and let's see, Jolie, what am I gonna get for the y component?
4.81 sine 45.
Wouldn't it be a negative or something?
Okay, so, well, okay, there's the question. So maybe not on this drawing right here, because these are just lengths on a triangle, right? But when I transfer it to my table, then I've got to be careful about the sign. Does that make sense? Because really, when I'm talking about the sides of a triangle, I'm just talking about lengths. So sure, this is 4.81 sine 45, but now, look at these two components. The x component is in the positive direction, the y component is in the negative direction. And so, adding these to my table, oh, what's this get? R for, no, what am I gonna call that? Thesis. But I already used S, that was
You
dumb.
do red scooters.
So this is gonna be, but R is resultant, so this is gonna be his,
It's Melvin's scooter.
M.
Oh, but that's confusing with the W.
Well, you know what we mean. So the scooter is Melvin Scooter. Is that a brand of scooter or something?
No, I just.
Oh, okay, all right.
I know.
All right. So the x component, positive or negative?
Negative.
The x component, positive.
That's really funny.
Yeah.
Okay, y component,
Negative.
negative, it's going down.
81. Whoa. There's a component.
Okay, so now we're set. Now all we have to do is just find the components
Or
of the resultant, right?
So wouldn't you just like kind of add them?
Yeah, you're just gonna add all these up, exactly. So this is really calculator work, isn't it?
yes.
Okay.
I could do it in mine.
I know you can.
So why is it that the one with the plane was so difficult?
Well, we'll go through one of those two. I think it is a little hard. Conceptually, it's hard.
Yes.
I mean, these, would you agree that now that you've done a few of these, you probably still have a little more practice to do, but I could give you one with 10 vectors, and it really doesn't make it significantly harder, just longer, right? I mean, if you just make a table with 10 lines then, right? Okay, so let's see if we can take care of this. So we get, we're gonna add these up. Oh, I can't, I have to go over here. So if we add those up,
11.
6.19 cosine 57 plus 6.33 cosine 45 plus 4.81 cosine 45 gives us that. Now I'm just going to, oh, Why didn't I say? This is just too much to keep track of for one person. So I'm going to approximate this decimal, but why don't we use the decimal on our calculator, right? So this is roughly equal to 11.2485.
Yeah.
Okay. What do I have to do to get this other list? Got to add those up. But remember the trick? All I have to do is just go up, grab this guy, second left, go all the way over to the left, and just change all of the cosines to sines and vice versa if you ever have,
But we're subtracting one.
Oh, and subtracting one, you're right, we gotta change the sign, no, you're right. So this first one's gonna be 6.19, thank you, Jolie, that was good. Sine plus 6.33
Sine
sine minus.
sine. Oh, you could keep those the same actually, because the 45 degree.
I could, you're right, I could. And boom. So we get
6.2.
Roughly. 6.2662. Okay, so then let's go ahead and find, we're going to build our resultant from that, right? Okay, so there are our components, x component and y component. So now we can build our resultant vector. So the x component is something akin to 11.2485, we'll use the calculator. The y component is something akin to 6.2662, use the calculator. And we get the resultant vector, what? So it comes out to be, what is it again, 12.9? And I think we just went to 3 places, didn't we? I'm pretty sure the sig figs were 3. So there's the magnitude by the Pythagorean theorem, right?
Yep.
Okay, how are we going to find, Schultze, how are we going to find the angle theta?
No,
We need to find the angle. Okay, does that make sense? Now look, we've got a right triangle. We know the opposite and the adjacent, right? And we know that tangent of theta equals opposite over adjacent.
How do you know it's that angle? What if it's
Well, okay, we know it's that angle because of the question. The question wants to know the direction of the scooter's velocity is blank degrees north of east.
Okay.
Okay? Make sense?
So the number
Yes.
1 was 4.9. First
No.
part of the question.
So the first part is
Yes.
12.9. Yep. Okay, so now the other part. So for the other part, we've got to take the arctangent of 6.2662, or better yet, on our calculator, we'll just grab that really precise number, divided by 11.2485, or better yet, use our calculator. So theta equals inverse tangent of that, which is what? 29.1. Okay, so that
What were we
is,
trying to find? Is the
angle.
scooter?
yep, right? Okay, so should we check it and make sure we got it right?
I think our sig.
So
when the zero's there on the 57, that means 3 significant digits.
Shh, I can't hear the question. Yes, say it again.
On
Yeah, okay, yeah, you're right. Okay, Clancy's got a good question. When that zero's there, does it mean, yes, it means that that is measured out to, because if it weren't, it would just be 57.
And then it'd be 2.
Then it'd be 2. But since there's the point zeros there, it's 3.
What's that rule they say, Mr. Cooper says, comes from what's right?
The ocean,
Atlantic.
the northern
The decimal's
ocean.
absent, the significant digits start in the Atlantic, and if the decimal's present, then the significant digits are coming from the
So
Pacific.
like on 57.0, you come from the left. Because
Yeah.
there's
Okay, do you understand that? Because I didn't understand that. As long as you get it, that's fine. Okay, so here's our preview. What did we say the first one was? 12.9,
yeah,
comma,
space. Well, maybe.
well, it didn't matter.
Times space.
Boom, okay?
That's a random 18.75 is what that was.
Yeah, it's just because it has to, it all makes sense, trust me.
It's from my textbook, like,
Okay, so let me show you one other thing on this, though. This was great. You guys did a great job with that. But I want to show you something, and this is kind of optional. Don't let this be confusing, but this is the way I would add the way I would do this is slightly different. Instead of defining any angles relative to any other axes, I would always define all of my angles the same way. If you define all of your angles as north of east, then the sign of the cosine or sine calculation, the SIGN sign, positive versus negative, will always take care of itself. You don't have to do it this way, but if you want to try it, it's pretty cool. So what I mean is, like right here, the first two were just 45s anyway, right? But the last one, when it was 45 degrees south of east, if I started here and went all the way around this way instead of going backwards 45 degrees, how far would that have been?
More subtraction.
315.
315. So if I either called it positive 315 degrees or negative 45 degrees.
Okay.
If I'm starting from due east and swinging the angle from there, right? And I would just always go the positive way, I think, then it's less confusing. Then, here's the beauty of that. Then whenever, I'm going to show you something. If I make it 315 degrees, somebody on your calculator, please tell me, what is 4.81 cosine 45? Actually, well,
3.4.
so about roughly 3.40.
Yeah.
Okay. What is 4.81 times the cosine of 315 degrees?
3.4.
So what's the big deal, Mr. Roy? How about the sine component? What's 4.81 sine 45? 3.41. Well, it should be
I got 4 out.
exactly the same,
Yeah.
right? Okay.
oh yeah.
Right. But now watch this. What is 4.81 sine of 315 degrees?
3.4.
What is it?
Negative 3.4.
Negative 3.40.
So it'll do
40, yeah.
So it takes care of the sines for you then. See what I'm saying?
Mm-hmm.
The advantage of that is also then when you're doing your calculator work, this is kind of just a cool little trick. Then I never have to worry about having as sharp of eyes as Jolie did. I never have to worry about changing any of these signs. Because if I keep the angle, the same angle, if I measure the angle all the way from 0 around, then all I have to do is just change cosines to sines and vice versa, and it'll work every time. Does that make sense?
Yeah.
Yeah.
Okay, don't let that be confusing. You don't have to do it that way. I'm not even encouraging you to do it that way. I'm just saying if you feel up for it or you want to kind of work in that direction, that's sort of a cool way to think about it. It makes the calculations a little easier. Okay?
You use that last vector as in like one more day.
Yes, I'm going to move. Okay, yeah. Here's what I think I've decided I want to do. Let's do this. Let's go ahead. I'm not going to do the test tomorrow. Do the test on, this is going to double up for you guys, but that's okay. I mean, it's really not that big a deal. For physics, calculus, it's not like I'm not going to, I promise I won't make you do any obstacle tests or anything. All you have to do is just answer some stuff on the computer. But I will I'll move both of them till Wednesday. And then tomorrow, because we're about out of time, aren't we?
Yeah.
Okay, tomorrow I do want to go through an example like the steering the airplane, because I think that's a pretty important
Yeah, that's
example.
a very important.
Yeah, so I'll go through one of those tomorrow, and test will be Wednesday. And then we're moving on, okay?
Roughly how many questions?
So Joey said.
5 or 6.
Oh, I'm so good.
Yeah, 5 or 6.
Perfect.
Yeah.
And yours was one.
Okay, let's see. Yes, Samantha's here. Samantha's here. Oh, there's Ann.
If someone ever tries to do that to me, I always just cut them off. Like I always make sure nobody's left lane in the game. Should be the right lane in the first place.
Sure, so that's